Because the most irreducible data type in R is a vector, that means that the basics of doing mathematical operations in R are a little bit different than what you might be used to. So a great deal of efficiency in our coding, it comes from the fact that it's built for handling vectors, which means it's built for handling iterated calculations with a minimal amount of code. So it can do things in one line of code that in many computer languages you have to write a loop to do. Now the basics of this are pretty simple, but you have to pay attention to the details because R will not throw any sort of error in some operations that you might expect an error in other computer programming languages. And the basic rules for how R is going to handle operations with vectors is to first of all do a element by element version of the operator. For example, if we have A plus B, it's going to add up the first elements of A and B, then add up the second elements of A and B, and create a new vector that has the sum of those elements on an element by element basis. And that works for all the operators. It will do the same thing if it's a subtraction or a division or a multiplication or a power or a conditional statement. It automatically will cycle through all the elements of vectors when doing operations. The next trick, though, is to keep an eye out for what causes a lot of bugs is to pay attention to how long the vectors are, because R will not throw an error if the two vectors of the operation are of different length. And the rule R will follow is to recycle the values of the shorter vector in order to cover all of the elements of the longer vector. Most commonly, this is for the purpose of taking a whole vector and multiplying it by a single number. Because if you recycle the shorter vector and the shorter vector only has one element, that means you're going to recycle that same single element for all of the elements of the other vector. So this is the reason that you can take a vector times an individual number in R, and you'll end up with a vector where all of the elements of the longer vector have been multiplied by that number in that single element. The only time you're going to get a bit of a warning from R is if you have two vectors where the smaller vector, the number of elements in the smaller vector does not divide evenly into the number of elements in the larger vector. That will cause R to throw a warning, though it will not stop the program. It won't cause an error state. So as usual, I'd like to spend a little time in an R console playing with how this works in terms of different types of recycling. So if we create a vector, call it A, and we say this will be a sequence of numbers from 1 to 5 by 1. A is a vector of 5 numbers. We can check on the type of A. It's a double precision floating point, which means R is going to do operations as if this is a real number as opposed to an integer, and the operation will be different depending on the type, so that's a good thing to pay attention to. So if we just look at A times 2, recall that this 2, as soon as R tries to interpret it, is going to get turned into a vector, and the vector will have one element. So that means R was going to follow the rules where it's going to recycle this single element to cover all the elements of A. And by following that rule, it's going to multiply each element of A times 2 and return another vector where all of the elements have been doubled, 2, 4, 6, 8, 10. If that vector is another vector, say we go a sequence of 5 to 1 by 1, made a mistake there. That should be -1. Apologies. Learning moment for all of us. Then we have a piecewise or element-wise multiplication because both vectors have the same length. One's going from 1 to 5, the other one's going from 5 to 1. So we get the product of the two, where the first element is 1 times 5, the second one is 2 times 4, the second one is 3 times 3, etc., etc. And we can see that we will get one of those warnings of vectors that are of two different, or where the smaller vector doesn't divide evenly into the larger vector in terms of number of elements. That will give us a warning message. Now, it doesn't give us an error. It actually goes ahead and does the recycling. It's just that it doesn't use all of the elements of the shorter vector in one of the cycles, and that's what causes the warning. So this is the only thing with this type of different sized vectors that will actually cause you to get at least some sort of indication that something weird might be going on. So be mindful of this, that these calculations will be carried out even if the vectors are of different lengths, and make sure that isn't causing an unexpected behavior in your program.